Hey team, welcome to the numbers game. I'm Coach T, and in this tutorial, we're going to be showing that the sequence is increasing and is bounded above. Now we're also going to find the limit of the sequence. Now before we get started, make sure to subscribe to the channel for notifications on more math tutorials. Alright, now let's take a look at this example. In this example, we're given a sequence where x sub 1 equals the square root of 2 and x sub j plus 1 equals the square root of 2 plus x sub j. And we're being asked to show that the sequence x sub j is increasing and that it's bounded above, and we're also asked to find the limit of this sequence. I like checklists, so I'm going to create one to keep track of all the things that we're being asked to do in this example. So let's start our proof by showing that the sequence is increasing. And to show that the sequence x sub j is increasing, we need to show that x sub j is less than or equal to the next element in the sequence, x sub j plus 1. Now we're going to prove this using induction, so we're going to start with executing our basic step. We'll set j equals to 1, and remember we're trying to show that x sub j is less than or equal to x sub j plus 1. So when j equals 1, that means that we're comparing x sub 1 and x sub 2. We know that x sub 1 equals the square root of 2, and x sub 2 equals the square root of 2 plus the square root of 2. And notice the square root of 2 is less than the square root of 2 plus the square root of 2. So we see that x sub 1 is less than x sub 2. Hence P1 is true, and we've executed our basic step. Now let's move on to our induction step. For our induction step, we'll fix x sub k to be less than or equal to x sub k plus 1, so we've replaced j with k, and we'll assume p of k is true. We need to show in this step that x sub k plus 1 is less than or equal to x sub k plus 2. Given the fact that we fixed x sub k to be less than or equal to x sub k plus 1 in our induction hypothesis, when we add 2 to both sides, we see that 2 plus x sub k is less than or equal to 2 plus x sub k plus 1. Then we can square root both sides to show that the square root of 2 plus x sub k is less than or equal to the square root of 2 plus x sub k plus 1. So here our square root of 2 plus x sub k represents our x sub k plus 1. And we know this because that's the information that we were given in our original example. So here we were given the information that x sub j plus 1 equals the square root of 2 plus x sub j. So when we replaced j with k, we saw we got the same thing. And then the square root of 2 plus x sub k plus 1 represents our x sub k plus 2. So we've shown that x sub k plus 1 is less than or equal to x sub k plus 2. Hence we've shown that the sequence x sub j is increasing. So I'll cross this off of our list. And let's move on to showing that the sequence x sub j is bounded above. To show that the sequence is bounded above, we need to show that x sub j is less than or equal to 2. So we'll execute our basic step again using j equals 1. And when j equals 1, we know that we're looking at x sub 1, and we know that x sub 1 equals the square root of 2. Again, we're trying to show that x sub j, or in this case x sub 1, is less than or equal to 2. And we know that the square root of 2 is less than 2, so therefore we see that x sub 1 is less than 2. Therefore P1 is true, and we have successfully executed our basic step, and now we'll move on to our induction step. For our induction step, we'll fix x sub k to be less than or equal to 2, where we've replaced j with k, and we'll assume that p of k is true. In this step, we need to show that x sub k plus 1 is less than or equal to 2. Now, given in our induction hypothesis we fixed x sub k to be less than or equal to 2, when we add 2 to both sides, we see that 2 plus x sub k is less than or equal to 2 plus 2. Then we can square root both sides to show the square root of 2 plus x sub k is less than or equal to the square root of 2 plus 2. At this point, I'll simplify the 2 plus 2 to give us 4 under the square root. And then I'll simplify the square root of 4 to 2. Now the square root of 2 plus x sub k represents x sub k plus 1 in our sequence. So we see that x sub k plus 1 is less than or equal to 2. Hence the sequence x sub j is bounded above, and we have executed our proof. So I'll cross this off of our list, and let's move on to finding the limit of our sequence. So let's start off with defining this limit that we're trying to find. We need to take note of the fact that the limit as j approaches infinity of the sequence x sub j equals c. Now at this point, I'm going to scroll back up to our original example to see if I can find some information that will help us evaluate this limit. So we're given x sub 1 as the square root of 2, but the information that's really helpful here is x sub j plus 1, which is the square root of 2 plus x sub j. This is the piece that's really telling us something about how this sequence is behaving, so we're going to use this to evaluate the limit. So in order to find the limit of x sub j, we're going to evaluate the limit of x sub j plus 1. And of course, this means that we're evaluating the limit as j approaches infinity of the square root of 2 plus x sub j. And essentially, we can say that f of x equals the square root of 2 plus x. Now, if f of x equals the square root of 2 plus x, let's consider the limit as x approaches c. In this case, c equals the square root of 2 plus c. And we're able to replace x with c because the limit of the function of the sequence equals f of c by definition. So at this point, we just need to solve for c, and we'll do that by squaring both sides. And that'll give us c squared equals 2 plus c. And then I want to get everything on one side of the equal sign, so that'll leave us with c squared minus c minus 2 equals 0. And then this factors down to c minus 2 times c plus 1. At this point, we see that c equals 2 or c equals negative 1. But c has to be a positive number, so the limit of x sub j equals 2. And there you have it. We've shown that the sequence is increasing, that it's bounded above, and we've also found the limit of the sequence. If this video was helpful for you, give it a thumbs up, like the video, drop a comment down below, and also subscribe to the channel for more math tutorials. I'm Coach T, and thanks for watching The Numbers Game.